Hello everyone, I'm Alfian and today we are going to solve the LeetCode challenge on the challenge number 118 called the Pascal triangle. And for this particular challenge, given an integer num rows, the number of rows, return the first num rows of Pascal's triangle. In Pascal's triangles, each number is the sum of the two numbers directly above it as shown. We have one right here and we have another one on the edges, and for the third row we have one which is calculated by the 2 from the top from the hexagonal pattern, and we got 2 as the answer by the addition right here, and we got the value of the 3 from the descendant on the left side and the right side of the hexagonal pattern, and we have value of 3. And then for the next one we have on the not the fourth row but on the fifth row we have the value of 1, 4, 6, 4 and then 1. So that is the visualization, and we have the example 1 right here. We have the number of rows which is 5 as visualized on the first example. Let me draw this for a moment. This one is the first row, and the next one which is the second row, and this part which is the third row, and this part from the horizontal line which is the fourth row, and finally this part is the fifth row. So the number of rows which is 5, and the output is stated as two-dimensional array with the value of 1 of each row, and then next one which is another one-dimensional array 1 1, and then 1 2 and then 1, and for the fourth one we have 1 3 3 1, and for the last one we have 1 4 6 4 1, which is in the form of two-dimensional array, and it grows as we traverse over the number of rows. And we need to calculate as the row grows. We need to calculate from the patterns, let's say from the hexagonal right here, hexagonal pattern from the left and right respectively. Then we need something to calculate on the red part that is being activated, not the red part but the orange part, I cannot tell. And we need some kind of 2 pointers in order to achieve this calculation, and we return the answer as the new form of the one-dimensional array. And for the example number 2 right here, we have only one row and of course the output which is 1 right here, and we have constraint which is at least one row and inclusive number to the 30 rows, number of rows. So we have at least one row to be returned, and if you notice on the first row and the second row we have both 1 and then 1 1 on this part, two-dimensional array. So it's always returning like that without any modification from the parent side. Okay, so let's solve this out by, let me visualize this by creating a principle of the Pascal triangle. We have 1 which is on the first row, and we have 1 and 1 on the second row, and then 1 2 1 which is derived. 2 we got the 2 derived from the first part, not from the first part but from the top part on the second row. And then for the next one we have 1 and then 3 which is derived from the left hand side. So hence we are using the 2 pointers right here to point out with 1 and 2, and then 2 and 1, and we got another 3, and then finally we got 1. So I will explain on the edges later on as we working through the array. And this one which is the third one, and finally this one is the fourth one. Okay, so let me explain the Pascal triangle. Oops. So for the first one we have 1 right here, the first row. So in order to get the descendant or the second row which is 1 and 1, imagine that you have an invisible 0 around the 1 like this, and then we got the 2 pointers pointing to the 0 and 1, and we got the value of 1 which is 0 added by 1 which is equals to 1, and another 1 right here we got from the 2 pointers from the left side and the right side which wrap this value of the first row is wrapped around the invisible zeros around it. So the second row we got the 1 and 1. And how about we calculate the third row in order to get the proper Pascal triangle? So we draw another invisible zero around the second row, which is 0, 1, 1, and then 0. But on the this invisible zero will not be counted as the final answer of the Pascal triangle that we calculate from the number of rows. So the next one, we have the value of the 1, and we already made the edges from the top to the top right and the top left respectively. So for the next one, which is left and right, we have 2 pointers, 1 and 1, we got the value of 2, and then another pointer which is pointing to the index, and we got 1 and 0, we get another 1. And finally we got the result of the third row. This is the third row, which is 0, not 0 but 1, 2, and then 1. And in order to get the fourth row, we need to draw another 0 around the edges of the 1 right here. So we get the value of 1, and then 1 with 2, we got the value of 3, and 2 with 1, we got the value of 3, and then finally 1 with 0, we got the value of 1. So we got the fourth one. So let's solve this code by creating, since it is already constrained by the at least one number of rows, so we don't have to worry about number of rows being 0 or anything above the value of the 30 because it is already inclusive number. So let's create an initial value. As we already know, on the first row we already got the 1. We will get 1 whatever the number of rows in, and we need to declare under a constant called the output, which is the answer output array, and takes in a form of number. And oh, I forgot to tell you something, that we are working with a TypeScript. If you want to use something else other than TypeScript language, then go ahead, I encourage you to do so. And we have the function of the generate, which is takes one parameter, number of rows, in a form of integer or number, and the expected output is in a form of two-dimensional array. So hence the returning answer will be the output. We have returned the output as the answer in a form of two-dimensional array, and we need to declare this number two-dimensional array as this is the one-dimensional array, and then we need to insert another one-dimensional array into the one-dimensional array. Then we insert in the 1, and we got the first row. And then so this is the two-dimensional array as the initial value, because we already know that the first row will also be 1. And we need to use a for loop. Use for loop for let I is equals to 0 as usual for loop, as long as I is below the number of rows, num rows, and then I++. So that way we are iterating over the num rows, and we generate the Pascal triangles based on the number of the num rows. Okay, so for the next one, we need to create another for loop to calculate the left and right pointer, and we generate the row as we traverse over the hexagonal pieces right here. So we declare another for loop, but before that we need to declare new array, constant new array, to be inserted into the existing output two-dimensional array. So the new array in a form of number array like this, just one square bracket. So it is declared as the one-dimensional array, and this one is the two-dimensional array. And the new array will be inserted into the output later on using the output push new array. But before that, before we are iterating over the hexagonal pieces of the row, we need to push the new array insert into the output two-dimensional array using the output push new array. That way we are inserting our newly created array into our output two-dimensional array. But before that, we need to process the new array using the for loop. For loop is in the let j equals to the -1. Why -1? Is because we are using the imaginary zeros before and after the actual value of the one right here, which is the tangible hexagonal. So we are using the -1 as the j variable of the for loop. Then we need to use the output of the current iteration of the current one right here, one dimensional array inside the output two dimensional array, and then using the output of the I dot length, I believe it's length, and then finally in the j plus plus. So we are, instead of starting from the 0, we are starting from the index -1, which is starting from the imaginary zeros around the 1 right here. And we need to declare the 2 pointers in order to get the 1 right here, which is 0 with 1, and we got the value of 1 right here, and another 1 with 0, and we got the value of 1 right here on the second row. So in order to do that, we need to declare a constant value which already know it's a number. Then we need to access the value inside the output of the current I, which is the 1 right here, and with the value of the j, and j, since j is pointing to the -1 instead of the 0 of the index 0, then it of course it will be returned as undefined. So how do we imagine this as the invisible 0 instead of undefined to be processed as the value? It is fairly easy. We are using the nullish coalescing operator using the double question mark and then passing the 0. This part, let's say if we have null or undefined value of the value that we are trying to access from the output, which is on the output of the index I, which is index I is pointing to the index 0 right here, which is this one dimensional array. And since on the index 0 we have the one dimensional array of 1, then we are accessing the j value, which is on the -1 right here. Since j value is the -1, it's supposed to be undefined. Then since the left hand side is already undefined, then the right hand side, which is 0 right here, will handle the undefined value, and it will return 0 instead of the undefined using the nullish coalesce operator right here. So instead of returning instead of returning the undefined or null, then it will use the 0 because 0 already handle this left hand side of the operator. And we need to wrap this inside a parenthesis, and then using the plus sign, and we need to calculate the next part, which is the index 0 right here, using the output of the I and then j plus 1. Why j plus 1 is because we are using double pointers, not double pointers, but 2 pointers, using the initial j of the -1 and then another j of the +1, which is j pointing to the index 0 right here, which points to the actual value of the 1 right here. So that way we are iterating over the value, and let's console.log the current value to see what is it about. Let's run this out. Whoops, we have the wrong implementation of the for loop. I forgot to include the semicolon, and we need to declare another j as long as j is below the output I.length and then j++. So let's run this again. And we have not a number value, so we forgot to handle this as the 0 to see if it is out of bound index. See the j+1 right here, which points to the undefined index or out of bound index. Then we return the 0 instead of the undefined or not a number. So let's run the code again to see if it works. See the console value, and we got the value of the 1, 1. So we off to a good start right here of the second row, which is 1 and 1. We need to insert the value into the new array using the new array.push of the value. And let's run the code again. And we got the correct answer, but on this part we got the additional value from the fourth row, not for the fourth row but on the fifth row. This part is the row 1, this part is the second row, third row, fourth row, and this is the fifth row, and this is the sixth row, but we only need to return the fifth row up to the point to the fifth row. So to get around this, we need to use the num rows, since number of rows we already declare as the 1 right here. Then number of rows should be reduced by 1. Let's run the code again to see if it works. And we have the correct value and the correct answer. And we have 2 milliseconds of the runtime. And let me explain something about this index out of bound. So from this part of the j plus 1, j of the minus 1, I'm sorry, and we are pointing to the j minus 1. Let's use this whiteboard. Let's draw another Pascal triangle. We have the 1, and then this, let's say from the underline right here, which is the tangible value, and the zeros are the invisible value. Since j right here is supposed to be pointing to the index 0, then j is pointing to the index 1. Since index 1 should be not a number or index out of bound, then it will return instead by the using the nullish coalesce operator, undefined, then it will return 0 instead. So minus 1, index of the minus 1 will return 0 instead of the undefined. Then the index 1 right here, which is on the index 0, and we have the value of 1, then we'll return 1 right here as the constructor of the new array of the value, and 1 will be inserted using the new array push, and we inserted 1 into the array. On the second row we have the second row, and for the next one, since 0 of the it's already 0, and since we are using the 2 pointers, and the next one which is on the j plus 1, which points to the index 1, since index 1 is not a number or undefined, is out of bound, then we will return the using the nullish coalesce operator, and we return 0 instead of the not a number. Then we compare both of the index 0 and 1, which is on this part. Output of this part, which points to this part is the index 0, and we got the 1, and this part which output j plus 1, which points to the, since j plus 1 is point to the index 1, since index 1 is out of bound from this index 0, then it will return 0 instead of not a number using this nullish coalesce operator. Then we will return 1 because it is a valid number, and then we are inserting 1 using the new Array.push, using this new Array.push, which is takes one parameter of the value inserted into the new array, and then the second one will be transformed into the 1, 1, and finally the whole of the output array, since we already have the 1 as the first row, then we are inserting is in the output.push, we are inserting new array like this one, which is 1 and then 1 into the two-dimensional array of the existing output array, and so on and so forth as we going through the number of rows parameter. So that is the rough explanation that we are trying to solve. That's about it. I hope you understand my explanation. If you still don't understand, you can ask me in the comment section, or if you have any better solutions regarding this challenge, tell us what you think in the comment section. Thank you for watching the video. I hope you have a great day, and I will see you in the next video. Goodbye.